Hello, hi everyone. It's Hitesh here. So let's start. The today topics will be a deep learning. Okay. So I'll be taking the deep learning concepts. Means what is meant by deep learning and why it is important, and what are the use cases of that particular deep learning. Okay. What are the applications of deep learning we have? Then we can say what are the different components we have in deep learning networks, and what are the different types of networks we have. Okay, this all the things we're going to discuss today. So starting with the deep learning, what is mean by deep learning? Okay, if you say what is mean by a deep learning, now actually it's a method of an AI. Okay, that is called artificial intelligence, which teaches the particular computers or machines to process the data in a way which is inspired by the human brains. Okay, that's why we mostly have a burst term called as a neural networks in a deep learning, because it gets inspired by the human brain. And this DL models, deep learning models, can recognize the complex patterns in the pictures, text, sounds, and other data to produce or get the accurate insights and predictions about it. Okay, you can also use the deep learning methods actually to automate the task which is typically required in human intelligence, such as describing the images or transcribing a sound file into text, and different other scenarios like converting the speech into the text and text into the speech. And this type of processes we use the deep learning concepts. Okay, we will see why it is important in today's era, because now the AI is getting very attempts to train the computers to think that learns, and whatever the humans can do that machines also can perform, that all the computational tasks. Okay, and better than the humans, the computation and this machine models can perform more accurately and very fastly, right? So the DL technology drives the many AI applications, and it is used in everyday products like such as you can say fraud detection, then automatic office facial detection, then voice activated television remotes we have, and digital assistants, the voice assistants. Okay, and in different parameters we have this particular deep learning. So it is also critical component of emerging technologies such as self-driving cars, where the deep learning is widely used, right? You heard about the company called as a Tesla, right? Tesla use the automatic self-driving cars. So in that particular concept only deep learning is having the greater impact. Okay, virtual reality and augmented reality, which is getting very famous nowadays, right? AR and VR, augmented reality and virtual reality. Okay, and much more this deep learning technologies has been used. Its models also you can say the computers files, and that data scientists have the train to perform some kind of a task using an algorithms only, and having the some predefined set of steps. Businesses use these models to analyze the data and make the predictions in the various applications. Okay, that's why it is important in different concepts and different scenarios. Now we will see what are the uses are there of the deep learning concepts. Okay, if we talk about, it has several use cases. Okay, in automotive industry, in aerospace industry we have, then in manufacturing definitely, electronics, medical research, and all the other fields, right? Some of the examples, if I'll take just now recent example I have taken, that is self-driving cars. Okay, which uses the deep learning models to automatically detect the road signs and the pedestrians. Okay, which heavily use the concepts of classification and the image classification and the computer visions in the self-driving cars. Next, so we have a, that is defense system, which uses the DL to automatically flag the areas of interest in satellite ranges or images, right? Then we have a, you can say, diagnosis analysis, which is in medical field, which is also called medical image analysis, uses the deep learning to automatically detect the cancer cells or the medical diagnosis, right? It is also used in factories, right? Factory uses the DL concepts and application to automatically detect what are the people or objects within the unsafe distance of machine, so which object has to classify in which particular domain, right? So these are the some use cases we can talk about the deep learning. Okay, and we can also, you can say, categorize this use cases of deep learning into four broad categories, which is called as an NLP. You haven't heard about it, which is called as a natural language processing for the voice assistant, AI chatbots, and all that particular concepts. Then we have a recommendation engines, and definitely we build a recommendation system engine, right? Because this Flipkart, Amazon, and the different shopping website, they uses the heavy recommendation system. Netflix also uses the recommendation system, right? They recommend the particular projects on the basis of the past data they're going to gather, and you're going to apply the algorithms. On the basis of that algorithm, they're going to recommend the future products and some products based on the customer interest, right? Then we have a computer vision and speech recognition. So these are the some broad categories areas in which deep learning is heavily used, right? Now if I come into the like a computer vision, it is the computer's ability to extract the information and insights from the images and videos. That is the computer visions, which uses the actually computer can use the deep learning techniques to comprehend the images in same way that humans do. And it also has several applications within the computer vision, like content moderation to the automatically removes the unsafe or inappropriate content from the images and video archives. Then in facial recognition too, it identify the faces and recognize the attributes like open eyeglasses or facial hair or what other things of they have. Then image classification, which identity brand the logos, clothing, safety gears, and other image details, right? Next we can talk about the other categories, the speech recognition, right? Actually DL models can analyze the human speech despite varying speech patterns, pitch, tone, languages, right, temperaments, and other accents. So virtual assistant, for that particular things only we develop the virtual assistants such like Amazon and Alexa, right? And it uses the actually automatic transcription software system, which actually assist the, you can say, that particular speech system to do the following tasks like assist the calling center agents and automatically classifying the calls, convert the clinical conversation into documentations in a real time, or accurately subtitle the videos and meeting recordings for a wider content research. For this particular concept, they uses the this automatic transcription software system. Then we have a natural language processing, definitely, which is the, just now I have explained you that computer uses the deep learning algorithms to gather insights, the meaning from the text data and documents, and ability to process that particular text data into natural and human created text, which has created the several other use cases like automated virtual agents and chatbots, then automatic summarization of documents or new articles, and business intelligence analysis of long form documents such as emails and the forms, then indexing of the key phrases which indicate the sentiment and such as positive negative comments on the social media. So in this concept, so we use the NLPs. Recommendation engine, definitely it uses the applications to track the user activity, and they develop the personalized recommendation systems for the different companies, which Netflix, Amazons, and the Flipkart uses the heavily this recommendation system. They can analyze the behavior of the various users and help to discover their new products or services, right? For example, I'll take another example, which is called as the media and entertainment, right? This media and entertainment companies use the deep learning and to give the personalized video recommendations like Peacock, Fox, Netflix, which we have talked about. Now the important thing is how, what are the components of deep learning we have. Okay, actually if you see, the deep learning consists of majorly three components, okay, which is called as an input layer, hidden layer, and the output layer. Okay, input layer is an artificial neural network, okay, and this neural network having several nodes that the input data into it. Okay, we're going to feed the data into this input layer only, and these nodes will going to make up the input layer of this system, and these nodes are connected to the hidden layer of the particular deep learning networks. Now the hidden layer, if we talk about, as we know that input layer will going to process and passes the data into the layers, okay, further into neural networks. Now these hidden layers process the information at a different levels and adapting their behavior as they receive the information, and depending upon the that layer configuration and layer algorithms we are setting into this hidden layer, right, it is going to behave depending upon the input data. And these networks have hundreds of hidden layers which can use to analyze the problems from the several different angles. Okay, suppose an example if I am taking, if you have given any kind of image of an unknown animal that you have to classify, right, and you want to compare which animals are already known which you have given. For example, you would take in shape of his eyes, ears, and his size, and the number of legs, okay, and its fur pattern. You try to identify the patterns in a several criteria, like the animal has hooves, so it could be a cow or deer, If the animal has cat eyes also, it could be the same type of a wildcat. Okay, category of a wildcat or belongs to the categories of wildcats. So in this way, this hidden layers in a deep neural networks works in a basis on the patterns, okay, and basis on the algorithms. And this algorithm which is trying to classify an animal image, okay, we're going to use the classification algorithms. And each of these hidden layers process a different feature of the animal and tries to accurately categorize it depending upon the data which we have fed along with the input layer. Last layer we have called as an output layer, which consists of the nodes that output of the data. Okay, and these deep learning models actually gives the output yes or no answers. Okay, because it have only mostly two nodes in the output layer, yes, no. On the other hand, those that are output of the wider range of the answers having the more nodes if the wider range of answers has been available given by the input and the hidden layers, right? Now we will see the difference between this machine learning and the deep learning. You heard about the term called as a machine learning, right? So many times you have heard the machine learning and the deep learning. Now, these might some kind of a differences. Okay. Now we know that deep learning is a subset of a machine learning. Okay, it is the core part of an AI because machine learning will going to perform well on the small to the medium data sets. Right? If you want to perform the data, if I'm taking the comparison with respect to data, then machine learning performs well on the small to medium data set. But in order to feed and in order to train the deep learning models and deep learning data, we require the heavily and large and humongous amounts of data sets in order to train the deep learning models. Okay, if I'll take to the comparison of hardware, okay, this machine learning models able to function on the CPU, that is central processing unit of a system, but in order to perform the deep learning neural networks, it requires a significant amount of computing resources, okay, and significant amount of computing powers. Example, it mostly works well on the GPU, okay, that is graphical processing unit. If you are trying to implementing the deep learning models on your CPU basis, okay, definitely that model is going to give you the number of epochs it will going to count and the number of epochs it will going to give you, it is very long, okay, and it will take so much particular timing in order to give the any kind of single input you wanted to process. Okay, respect to features, machine learning actually needs to be a manually identified. Okay, if I want to identify any kind of certain criteria, if I want to do any kind of feature extraction, then it's to be a manually identified into the Python programming. Even if you are doing, we have to testify, we have to debug that particular program. But this deep learning actually learn the features automatically. Okay, in feature extraction of the machine learning, we have to do the means debugging and all the manually identifications, and we have to feed to the input data, then definitely I'm going to get an output. But in case of a deep learning, we have to actually that model only learn the features automatically, right? Now you might be heard about the terms called as a ChatGPT nowadays. Okay, this ChatGPT actually heavily based on the deep learning neural networks. Okay, it's heavily based on the concepts of deep learning. Okay, every day now around the world, so we are feeding the data to that particular ChatGPT, and on the basis of that particular ChatGPT is giving the output. Because at the time of the creation of this model ChatGPT, the data has fed to him around the 3 billion words. You can take about, and now every day is just getting that feeding into the model, and that model is just trying to generate on the basis of the data which is giving to the input layer, and on the basis of there are thousands and lakhs of millions of hidden layers has been present, and that hidden layers will give the different outputs. Right, so these are some differences between the machine learning and the deep learning. Okay. Now we will see some deep learning frameworks. Okay, in order to work with the deep learning, we require the deep learning frameworks. So one of the famous deep learning frameworks, we have a TensorFlow. Right, this TensorFlow has been given a very vast advantage over the different you can say NLP concepts and the different you can say classification concepts or even the machine learning concepts. Okay, it mostly widely used for the you can say optimizations techniques and for the performance tune testing techniques. Okay, if they have to manage the dependencies or the manage classifications, okay, we use the this TensorFlow. Next we have a PyTorch, which is actually a Python package that provides the two high level features. One is a tensor computation like NumPy, but with a strong GPU acceleration it needs. And one is a deep neural network, that is a DNN, which is built on the, you can say, AutoGAT system, right? Actually, the modern deployment in PyTorch becomes little bit easy because we have to use the Torch Tensor RT integration to optimize and deploy the models within the PyTorch. Okay, and export that is PyTorch model into the ONX format, and after importing that particular format, we optimize and deploy with the NVIDIA Tensor RTM, which is the software development kit for the high performance deep learning inferences. Okay, TensorFlow, which I have already told you about, the that is an open source software library for the numerical computation which uses the data flow for numerical graphes. Okay, we also have Lex, which is very important nowadays, getting famous. That is a JAX. Okay, it's a Python library again which is designed for the high performance numerical computing and machine learning research. You can automatically differentiate the native Python and implement the NumPy APIs. It is just a few lines of code only. This JAX enables a distributed training access to the multi-node and the multi-GPU systems with the accelerated performance of XLA optimized kernel on NVIDIA GPUs. Right. Then we also have a PP, that is the paddle, which is also called as PP, which provides the intuitive and the flexible interface for the loading the data. Mostly, if I remember, this PP has been supposed the CNN, okay, convolutional neural networks and the RNN, that is recurrent neural networks, okay, and multiple variants which easily configures the complicated deep learning models, okay, because it provides the extremely optimized operations and memory recycling and network communications, which make easy to actually this scale the heterogeneous computing resources and storage to accelerate the training process. So because the model deployment is also a little bit typical in this paddle because it uses the tensor RT and the deep learning interfaces for the ONXS system, right? But it have the integration with the tensor RT in order to optimize and deploy the deep learning models. Okay, we have talked about the MaxNet. Like MaxNet is just a DL framework only, deep learning framework, which is designed for both efficiency and the flexibility, which allows you to mix the flavor of symbolic programming and the imperative programming method in order to maximize the efficiency and productivity of its development environment. And it's also its code is actually dynamically dependent scheduler, which automatically parallelizes the symbolic and the imperative operations on the flies. Okay, so coming to the next topic, which is having the models. We have discussed about the different actually models, like model deployment in different frameworks, how it works. So for today, this is all about the deep learning concepts. Okay, now if you wanted to learn in deep how this all the algorithms, what sort of algorithms we applied in deep learning models and how we can implement these learning models with the help of the Python, so you can connect to the Coachx.Live. Definitely they're going to guide you at the best level. So for today guys, I'm just setting for now. Tomorrow I'll come again with a new and next topic. So till then, bye bye, take care and see ya.